like you're shooting out. When you're done, if you could, just for right now, on your homework, 3.5 to 3.6. You know what we did yesterday where you put in your calculator? You know what I'm talking about? There's 3 of them in the back. One like this, numbers 9, 16, and 18, I believe. If you could go ahead and try that, and I could come around and help if need be, but we'll do one here in a bit. Okay? If you could work on that while we're waiting, that way we can get some of that done. Not have to worry about the weekend. You good, Diego? Cool. We could actually look at it now if y'all are good with it. I think we've got about 13 minutes left. My game plan was to try to get some of this homework done. It's due on Sunday, but we could really dominate and get it done here so we don't have to worry about it, all right? Before I do that, though, talk to me. How did the quiz go?
That was good. Pretty easy.
Good? Yeah? Okay, cool.
Can I go now?
Yeah, you may, absolutely. 3.5 to 3.6 is the only other section we're going to hit on. It's kind of combined, so it's kind of a combined section. But this section will be the last part of the review process before our test, which will be our test will be Tuesday. Okay. Remember, too, Tuesday's test will also be kind of combined between 3.1 to 3.6. But note that we've actually been doing it anyway. Like, you may not have known that, but like combining, condensing, expanding. We've been doing a lot of that as it is already. So just a heads up there. I'll give more information come Monday when we're going through the review process. Anybody have any questions on how I plug this in my calculator? Y'all need me to go through it again?
Yes.
Okay, well, cool. We'll do the first one. So on I think it's number 9 that you're doing. Remember, don't do all of them. It just says do numbers 9, 16, and 18, and it's number 9 on your homework, okay? So if we could look at number 9, what do we put in? Well, first of all, how do we start this? Yeah, good, Hannah. So we're going to go ahead and go to stat there, and then you're going to go to your edit side. If you remember our activity yesterday, this idea of exponential growth, exponential decay with the disease, that's what we were kind of looking at here. So we'll make sure that all of the lists are cleared. And then on L1, we'll put all of our what values? Good, yeah, Jay, good. So all of our X's go on our L1 and all of our Y's go on our L2. So like for number 9, you'll put in 1, 1.5, and I'll just kind of, we'll roll through this. 1, 1.5, 2, 2.5, I think it goes all the way to, oh no, scratch that, 4, 6, and 8. Okay, so 4, 6, and 8. Cool, so that's our X list right there. To go to our Y list, or our L2 list, we're just going to put all the Y's in there. So 2, 3.5, 4, so we're just going to 3.5, 4, 6, or for, hold up, 5.8, 7, 7, and 7.8, okay? .8. All right, good. Questions there? Pretty simple, just plugging it in. Then we're going to go into our graph. If you remember we went to graph. It may look kind of weird, like right now this looks really strange. So you may have to go to your Zoom stat, which is again your number 9. And when you see this is the graph that you will perceive there. The question asked, decide whether the data could best be modeled by a linear model, exponential, or logarithmic model. So in this example, what would you say would be the better model? I would say linear could be. I would say there's even a better one than that. But I think that's pretty close. I don't think that's a bad representation there. Exponential would be like going up or coming down, right? Do you remember what does a log look like? Like a log would go this way, right? Here's the y-axis. That's what it would look like. Does that look like this? Yeah, it kind of does, right? So it kind of goes downward. So I would say logarithmic model. That's what I would say. Okay. Remember on number 16 and 18, because you did that whole column on number 9, you're good. On 16 and 18, you'll do the same thing, but this time you'll actually find the equation. Are y'all pretty familiar with finding the equation and doing that? Kind of, sort of. Okay, so if I was to do it with the data that I have, I'll go to Stat, Calc, and then for this one, they just want our exponential regression. So all of those ones on the second kind of box over there is exponential regression, and that's where I just press Enter. And usually you can just go enter, and all the way down to the bottom, and then press Calculate, and you'll be good to go, okay? Cool beans. And that would be the number 16 and 18, kind of that same idea there. Okay? Cool.
Coach Jay, do you have
Yes, sir.
another one of these? I think I lost one.
I think I've got extras on the bottom right there, Dave. I do have this one, so if you need it, you could use this one. There's only one other one that I wanted to look at, and then I'll let you kind of go. There's really 2. Real quick, this one's like easy, and I think it might be kind of similar to one that's on there. Number 8, there's one of them on number 8 similar to this. It says the number of bacteria is given by the model where t is time. So if n is equal to 300, when t is equal to 5, estimate the time required for the population to double in size. Okay, so think about this. Start us off. If n equals 300 and t equals 5, what could I do with the equation that's above? Just plug it in, right? So pretty much kind of the same thing we've been doing. 300 equals 100, e to the k times 5, right? So what do I do to get k by itself? Good. Then what would I do then? So we have 3 is equal to e to the 5k. ln on both sides. Kind of the same thing we did today, right? ln on both sides. And then ln of 3, then I divide by 5, gets me what? What'd you get, Hannah?
0.21. I don't know if you want to do that. 0.22.
Yeah, so we just say 0.21. That's fine. So 0.21 is k. So then the question came up, after this, estimate the time required if I were to do that again for the population to double in size. So in this example, if 100 is kind of our starting point, right? Our n would be what?
600? Or is it?
That's like when we double. Yeah.
I would. That's a weird way of kind of writing it. I would say 600 too.
Yeah, I'll say.
Doubling from 300.
Yeah.
I like that. I was kind of reading it a little bit, but I would say 600 equals 100 e to the 0.21 t, and you would solve for t the same way we just did, right? Dividing by 100, taking the ln, and then moving from there, all right? Y'all follow me on that? That one is kind of like the website growth problem that's there. Do you see that one, number 8, comparing models? Y'all see that one? Right here on the, I think it's on the application side, bottom left. You could throw that one out, okay? So the bottom left-hand side of this, the one that says comparing models, throw that one out. The one that I really want you to know is the website growth, the one we kind of just did, where you have to solve for k first, and then once I solve for the constant, I could plug it back in and rock and roll, okay? The depreciation one I would want you to do. For these two, for that one specifically, kind of comes back to this problem over here where we took, like we have our x, which is your time. Oh, I'm sorry, not time. I was trying to see what t represents. So 8,600 laptops would be your x. Your cost would be your y. And what you would do is then try to attempt kind of to figure out what the two points would be. And then you'll do a linear model and then an exponential model and then kind of go down from there. And I was right when I said it earlier. The time would be your x-axis, and your y would be your cost. So your cost would be up here. Does that make sense?
The cost would be
1150. Yeah. So. Oh yeah. I was looking at it, I was like, what is the time? So when it's new, when time is 0, your cost is 1150. So think of it as like the point is 0, 1150. But it depreciates, right? Just like a car does. So what would be the second point? What would be time? Good. 2, 550 would be kind of the second point. So based on those two, you'll plug it in kind of like what we just did. And then when you go to stat, calc, go to linear regression, find the linear point, and then go ahead to the exponential regression to find the exponential point. And then from there, you kind of can go down, and the next parts are just plugging things in, comparing the models that are there, and then plugging things in, going from there. Just remember that the x is time, and the y is cost, and you should be okay on that part. Does that make some sort of sense? Cool. All right, what do y'all think? We good so far? All right, can I give you one more? We're kind of just hitting some random ones. Let me give you the last one, okay? This one that we're looking at is on the second page. Do you see number 6 right there? Let's look at number 6 real quick, and then we could go. We'll finish off on this one, okay? All right, the question asks, what is the linear equation if we have 2 points? So we have y equals a times b. Oh, I'm sorry, this is a different one. A times e to the bx power, okay? In order to solve for this equation, you need 2 things. You need a and you need b. Got me? Okay? So if you look at 0 and 1, that is 1 point where 0 represents what? X, and 1 represents y. So what I'm going to do is on this first equation, I'm going to plug 0 in for x and 1 in for y. So it should look like this. It should be 1 is equal to a times e to the b times 0. I just plugged x and y in for that. Y'all follow me? Okay. Well, what's b times 0? 0. What's e to the 0 power? 1. Very good. So 1, this right here is 1 times a is what? A. So a is equal to 1. Y'all follow me so far? We're good there? Okay, I just plugged it in and simplified. So what about 310? Well, let's do the equation again. This time 3 goes in for x, 10 goes in for y, and 1 goes in for a, right? You follow me? You're just plugging it in again. So we would say that 10 is equal to 1, which we just found, right? E to the b times 3. Cool? Well, what is b times 3? That's just 3b, right? If I divide by 1, that just gets me 10, right? So you're saying 10 is equal to e to the 3b. And how do I get e out of there? ln. Then how do I get that b by itself? Divide by 3. And once I get that, that would be my b value, whatever that would be there. And then when I plug it into the equation, again, all I need is 2 things. I solved for A, I solved for B, and then we're good to go. Okay. Cool.
Broadcast tackle will be in the PAC today.
Y'all like these?
Reminder, broadcast tackle will be in
Well, the seats are more comfortable because they have cushions.
I like the PAC, more intimate.
I like it for work.
Cool, cool. Hey, y'all have a good weekend. Anyone doing something cool this weekend?